This recording will discuss the indeterminate forms of the type 0 to the power 0, infinity power 0, or 1 to the power infinity. The famous examples are limits of x approaching 0 from the right, 1 plus x raised to the power 1 over x, or limit of x goes to infinity, 1 plus 1 over x raised to the power x. Let's look at what are the indeterminate form here. We know that when x approaching 0, 1 plus x will approach 1 as x approach 0 for the right, and 1 over x will approach infinity. So you're going to have 1 power infinity. So you expect the answer is 1, but this is not true. Similarly, if you let x goes to infinity, for the second case, we know 1 over x will goes to 0. So 1 plus 1 over x will goes to 1. And then you have the case of 1 power infinity again. And what is this number? Is it equal to 1 again? The answer, unfortunately, is no. The argument I just presented are illogical. Now let's look at what is the actual answer when x approaching 0, and then look at 1 plus x power 1 over x. So I'm going to take a very small number. For example, for the first example, for 1, let's say x is a very small number, let's say 1 over 10,000. Then what is actually 1 plus 1 over 10,000 raised to the power 1 over x, which is 10,000, equal to, let's press my calculator. So I'm going to write 1 plus 1 over 10,000, close the bracket, then raise to the power 10,000. You find that this number about 2.718145. Are you familiar with this number? This number is the Euler number close to E. Alright, so the actual answer for the first limit is E. Similarly, you can find the second one using calculator. You find that this number is E as well. Let's look at the graph. From here you can see the graph of 1 plus x raised to the power 1 over x, which I shown here. Now if you let x goes to 0 from the right, then you'll find that as x approaching 0 from the right, you see that the y, which is 1 plus x power 1 over x, will approach the number about 2.7 something, which is E here. That's why you have limit of x goes to 0 plus 1 plus x power 1 over x is E instead of 1. Let's look at another case. This is the graph of 1 plus 1 over x raised to the power x. You find that when x goes to infinity, the value of y approach about 2.7. So I can write limit of x goes to infinity, 1 plus 1 over x raised to the power x is E. What is the strategy now if we don't have the graph to help us? For indeterminate forms of the type 0 power 0, infinity power 0, or 1 to the power infinity, sometimes we introduce a dependent variable y, which is fx raised to the power gx, where, for example, limit of fx is 1 and limit of gx infinity. Take ln y will be equal to ln of fx power gx, using the property of ln function, I can bring down the gx. It becomes gx times ln fx. And then we can convert this into 0 times infinity, indeterminate form, or 0 over 0, indeterminate form, or infinity over infinity. And then you can apply Hopital's rule to evaluate the limit. Here is example 6. Limit of x approaches 0 for the right, 1 plus sine x raised to the power 1 over x. This is the type of indeterminate form 1 to the power infinity, because we know that when x approaching 0 from the right, 1 plus sine x will approach 1 plus 0, which is 1. And when x approaching 0 from the right, we know 1 over x will give you infinity. So this is the type of the indeterminate form 1 power infinity. So the strategy is like this. We're going to let y equal to 1 plus sine x raised to the power 1 over x. So we are trying to find the limit of y when x approaching 0 from the right. The method is take ln both sides. Ln y will be ln 1 plus sine x power 1 over x. Now using property of ln function, we know ln of m power n is n ln m. So we can write them as ln y is equal to 1 over x times ln 1 plus sine x, or as a ratio of ln 1 plus sine x over x. So we have a situation now. We're going to find the limit when x approaching 0. What happened to ln of 1 plus sine x over x? So let's examine this problem now. X goes to 0 from the right, ln of 1 plus sine x over x. If you let fx equal to ln of 1 plus sine x, and let gx equal to x here, then we know that f and g are continuous and differentiable at the point x equal to 0. Moreover, f0 is ln of 1 plus sine 0, which is ln 1, since sine 0 is equal to 0, and ln 1 is also 0. And obviously g0 is equal to 0 there. So all the conditions of the Hopital's rule are satisfied. So you can find the limit of this ratio here using the Hopital's rule. Differentiate ln 1 plus sine x over differentiation of x. Now you recall, how do you differentiate ln of 1 plus sine x? So recall, differentiation of ln of 1 plus sine x is equal to 1 over 1 plus sine x, and then differentiate 1 plus sine x. And this will give you cosine x over 1 plus sine x. And we know differentiate x to get 1. So this is the same as the limit of x goes to 0 from the right. Denominator is 1. Numerator is cosine x over 1 plus sine x. Now when x approaches 0, cosine 0 plus over 1 plus sine 0 divided by value 1. And we know cosine 0 is 1, sine 0 is 0. And so this is 1 over 1 is equal to 1. That means that when x approaches 0 from the right, ln y, which is equal to ln 1 plus sine x over x and it's the same as this expression, and we find that this is after applying L'Hopital's rule. You find that this limit is 1. So if ln y approach 1, what will the value of y? That means that where is my y now? That means this is the situation, limit of x goes to 0 from the right, y. So that means that limit of y when x approaching 0 from the right is e power 1. And that means I've got my answer already. The limit of x goes to 0 from the right, 1 plus sine x raised power 1 over x is e. So that concludes our calculation of this example 6. The answer for 1 plus sine x raised power 1 over x when x approaching 0 from the right is e. Now let's look at the graph of 1 plus sine x raised power x. This is an interesting graph of y equal to 1 plus sine x raised power x. But what we are really interested is what happens when x approaches 0 from the right. That means when x approaches 0 from the right, what happened to my y? Notice that y going to be have this value, which is about 2.7. If you zoom in to find what happened to the graph, say this is the portion of the graph from x between 0 and 0.5. When you zoom in and find out when x approaches 0, and then you find that the y approach the value about 2.7 something, limit of x approaching 0 from the right, 1 plus sine x raised power 1 over x is e, using the graph to help us. But we can actually get this without the help of the graph by using the L'Hopital's rule. By introducing a dependent variable y first, then take ln both sides and apply the L'Hopital's rule to obtain the answer as e, using the continuity of ln function. That is the end of this recording.